I hope you are able to see the board.
Yes, sir.
Thank you. So we went as far as I didn't keep the recording, but we did to sheet 3, 4, 5, 6. And question 6. So to sheet 3 was completely done. So we want to start preparing for to sheet 4. And the best way of doing to sheet 4 is first having an idea of what is in sheet 4, and then we'll be just tapping it as our examples. So we start looking at inequalities. So look at inequalities. If I can make this thing big. Okay, yeah. So look at inequalities. So for inequalities, we have got several types of inequalities. Type 1, we have a type of this nature where I'm dealing with f of x greater or equal to a, where my f of x is just a linear function, say x plus 1 greater or equal to 3. If I have such an inequality, the only task that I have to do is to take this one the other side. So we have x greater or equal to 3 minus 1, meaning that x is greater or equal to 2. And this becomes the solution. You can also write this as an interval where you say 2 all the way up to infinity. You can as well do so. Or another example, so this was A. B, I can have negative 2 here, less or equal to 3x plus 4, which is less than 7. If I have such an equation, I can take this number the other side, but if I do so at the same time, I must take it the other side. Meaning we have negative 2 less than and minus 4 less or equal to 3x less than 7 minus 4, indicating that we have negative 6 less or equal to 3x less than 3. And then divide by 3, divide by 3, divide by 3, giving us negative 2 less or equal to x less than 1. This is telling us that we initially had negative 2 less or equal to 3x plus 4 and 3x plus 4 less than 7, giving us negative 2 minus 4 less or equal to 3x. At the same time, 3x is less than 7 minus 4. So that here we have negative 6 less or equal to 3x divided by 3 divided by 3. And 3x less than 4, less than 3. So you divide by 3, divide by 3. The other side would get x is less than 1, and the other side would get negative 2 is less or equal to x. Then you put these two together and say my solution set then is -2 less or equal to x, but this very x is less than 1. You can as well keep it as an interval where you include -2 because of the less or equal to, and exclude 1 because you only have less than. Do we have questions this far?
No, we are clear. No, sir.
Okay. We can also have a question of this nature. Now I've picked from the actual tutorial sheet. We also have this type greater than 0. So this type will force us, because in inequalities, we do not cross multiply a variable. The reason is, if I'm having -3x less than 7, if I divide by -3, I divide by -3, x will be greater than -7/3. Meaning that the inequality will change from less than to greater. This means that if we divided x and divided x here, would have remained with this less than that. But we don't know. What if x was negative? The inequality should have changed. Now it has not changed because we don't know what x is. So that's the more reason why we do not cross multiply a variable. So it's the reason why we don't cross multiply a variable. Okay. So I'm trying to learn these things. Good. Okay. So what are we going to do? What we'll do is we will say we'll look for critical values. By equating x minus 2 to 0, find 2. Equating this to 0, find 5. And then form a table. So the table will be 2 here, 5 there. Pick a number bigger than 5, say 6. A number in between 2 and 5, say 3. A number less than 2, say 0. And then pick x minus 2, and then x minus 5. Then we'll have x minus 2 over x minus 5. And then test our numbers. The secret here is when you have greater than 0, we mean the number line is here. This is 0. Any number that comes after 0, any number that comes from here going this side is positive. And any number that comes from here going this side is negative. And this part is less than 0, and the other part is greater than 0. Meaning that whenever we have greater, our interest will be going for where there's positive on the last line here. So let's test. When x is 0 in x minus 2, we'll get -2. Our interest is just a negative. When x is 0, we'll have 0 minus 5, which is negative. So So if we divide negative divided by negative, we get positive. When x is 3, you have 3 minus 2, which is positive in that table there. And then 3 minus 5 is negative. Positive divided by negative, we get negative. 6 minus 2 is positive. 6 minus 5 is positive, so we get positive. So the solution set here is where it is greater than 0. Meaning, we'll get from negative infinity all the way up to 2, not including anything, union from 5 all the way up positive infinity. So what are we taking note of? You say when we have greater or equal to, get the positive intervals. One, two, when we have less or equal to, we get the negative interval. So get the negative intervals. So you must always, so this is helping us to know what to get when we have what. So if you have a fraction, you go to the table. So whenever I have a fraction, whenever there is a fraction, use the table. Okay. So another type we'll call it, so this was our example 2. What was A, B, then we said 1, okay, 2. So now we'll say 3. A different type, if we have 2x squared plus 3x is less than 14. So I'm picking this from the Tero sheet, but I'm picking them as varieties. So this is telling us that do 2x squared plus 3x minus 14 less than 0. So this is a quadratic. So we need to factorize it. So factorize the quadratic. For you to be able to get the critical values. So how we factorized? So we have 2 by negative 14, that is negative 28. Two numbers, when we add, we get 3. When we multiply, we get negative, when we multiply, we get negative 28. So we have the product is negative 28. The sum is 3. So what are the factors? So I'm thinking here, the factors will be 7 and 4. 7 and negative 4. So that we have 2x squared minus 4x plus 7x minus 14 is less than 0. So 2x, x minus 2 plus 7, x minus 2 is less than 0. So we have x minus 2 multiplied by 2x plus 7 less than 0. Whenever we have the product, again use the table. So get the critical values. X minus 2 is equal to 0, giving us x is equal to 2. Get also 2x plus 7 is equal to 0, giving us x is negative 7 over 2. And then form a table. So negative 7 over 2. Let me put the table somewhere else. So I'll put the table here. Negative 7 over 2. 2. A number in between here would be 0. A number less than that, we can go as far as negative 10 to be very sure, so that we don't even have to start dividing there. A number bigger than 2, even 3 is okay. And then we get x minus 2. We get 2x plus 7. We also get x minus 2, 2x plus 7. So we have these lines. Okay, so when x is negative 10, we have a negative here. We also have a negative here, giving us a positive as a product. When x is 0, we have a negative here and a positive here, giving us negative. So where are we taking those numbers? We are substituting. When x is negative 10, you substitute in x minus 2, we get negative 10 minus 2, which is negative 12. Don't bother yourself about the 12. Just get the negative. When x is negative 10, in the other one, we have 2 negative 10 plus 7. That is negative 20 plus 7, which is negative 13. Forget about the 13. Your interest is in the negative. Then multiply the two negatives to give us a positive. So do the same to 0. And now we move to 3. So 3 minus 2 is positive 1. We just want positive. And 3 times 2 is 6 plus 7. We still have a positive. Multiply them, we get a positive. So what is our solution set? So the solution set here, remember we said when we have less or equal to get the negative intervals. Now here we have less. So what are we going to do? We'll get the, so for less, we'll get the, that's how it runs. Yeah. Okay. So for less, we'll get from negative 7 over 2 to 2. So close there like that. So not including any. We don't include n because it's strictly less. So you will see when it is necessary to include something.
Sir.
So where we
Hello?
hello.
Yes, sir. I have a question concerning the previous example that we had. What if
Okay.
that same fraction was equated to another fraction instead of zero? How are we going to come up with the the what's this the critical values we're going to use for the table?
So we would have done this very thing that we did here, taking negative and taking 14 the other side. So we would have taken that fraction the other side, and then put the two fractions together, get the common denominator, do the computation for the numerator, and then equate the numerator to 0, the denominator to 0 to get the critical values. So we never solve them separately, we combine them.
All right, sir. Thank you.
Okay. In fact, okay, so we're moving slowly. Let's move to 3. So I'd code this one 3 also. Okay, so I'm coding the 3 now because we are tackling the tool sheet. So we have done question 1 on the tool sheet, also done question 2. Now we'll do question 3. X power 3 over x squared plus 1 is less than 0. So this one is already in the standard form. All we need to do is to get the critical values. The critical values we have for the numerator, x3 is equal to 0, implying that x is equal to 0. For the denominator, x squared plus 1 is equal to 0, implying that x squared is equal to negative 1. Try to get the square root here, and there you have x is equal to the square root of negative 1. This is not possible. So because it's not possible, you know that we only have one critical value, which is 0. So your table is just a simple thing, 0 there, and then we can demarcate I want it to be 0, so 0, and then draw a line there. Pick a number bigger than 0, say 1, a number less than 0, negative 1, and then get x power 3, then get x squared plus 1 if you want. If you don't want, just get x3 over x squared plus 1, because we know that the middle part there won't change any sign. So we have this. This is a plus here. Okay. So we take negative 1. What is negative 1 to the power 3? We'll get negative 1. So we have negative. Then you take negative 1, square it, then add the 1. For sure, it will be 1 plus 1, which is 2. We're interested in the sign, positive. When you multiply the 2, we'll get a negative. If you take 1, it will be plus, another plus, so we'll get a plus. Okay? So this means that since we have less, our solution set should be from negative infinity all the way up to 0, not including anything. So it's possible also that even if we have a numerator and a denominator, one of them can fail to give us any critical value. So forget about it in terms of critical values and move with the one that gives us critical values. Do the testing and get the required data. So now let's see the form which you asked about, we have it on part 4 of the tutorial sheet. Part 4 is giving us x squared minus 4x minus 21 over 3x plus 9 greater than 4x minus 21 over x plus 5. So these are two fractions. So the easiest and formal way is to get the other fraction, bring it this side, over x plus 5 greater than 0. And then get the common denominator, 3x plus 9, x plus 5. So divide that one here, we'll get x plus 5. So have x squared minus 4x minus 21 multiplied by x plus 5 minus 4x minus 21 in brackets multiplied by 3x plus 9 greater than 0. Expand the numerator, so have x power 3 plus 5x squared minus 4x squared minus 20x minus 21x minus 105 minus, we expand the other one, 4x by 3x, we get 12x squared plus 36x minus 63x minus 21 by 9, we get 918, 189. Everything over the already factorized thing, 3x plus 9 and x plus 5. This must be greater than 0. So we do the expansion, so we have x3 plus x squared. So we simplify 5x squared minus 4x squared. Then negative 20 minus 21, that will be minus 41x minus 105. Then minus 12x squared as we expand there. Then 36 minus 63, we'll have 63 minus 36. That is 5 there, 1. 13 minus 6, we get 7. And then 2. So we'll have negative 27 x to be made plus because of this negative outside here. And then that will also be plus 189. Everything over 3x plus 9 and then x plus 5 greater than 0. So what will happen next? The x3 is reserved. The x squared now we add, so we'll get minus 11x squared. The x also we add, negative 41 plus 27, that is the same as 41 minus 27. That is 11 there, so we get 4. A 3 will remain, so we'll have 1. So we'll have 1, giving us x3 minus 11x squared minus 14x And then 189 minus 105. 189 minus 105. That is a 4 there and 8 there. So we get 84. And it will be plus. So we'll have plus 84. And everything 3x plus 9. And then x plus 5 greater than 0. So when we reach this point, we now have a polynomial in the numerator. So you look for factors of that polynomial so that you have it factorized and then get the critical values. So because you guys, at least you have an idea of what polynomials are. Even if we have not done polynomials yet together, we can attempt this question because we have an idea of what polynomials are. So we'll talk about it a bit for the sake of this question, but we'll elaborate more when we look at polynomials themselves. So we get x3, x power 3 minus 11x minus 11x squared minus 14x plus 84. So let's get this and equate it to 0, meaning that we factorize this thing. So to solve a polynomial,
Sir. Sir.
Hello?
I'm kindly asking if you can go to the previous slide. I just want to check something for a minute. All right, so thank you very much. You can move forward.
Okay. So we need to factorize this thing. Factorizing a polynomial, you look for its zeros. So find the value of x that makes this thing 0. Now you find the value of x by trying. So get the factors of the constant, this one, or the coefficient of the greatest, the highest degree. So in this case, we have 1x to the power 3. So we can use 1 if it works. But of course, here 1 cannot work, we can see. So we get the factors of 84. So we can start from 2. So we try 2 to the power 3 minus 11, 2 squared minus 14, 2 plus 84. Can this give us 0? Let's see. This is 8 minus 44 minus 28 plus 84. Can this be 0? No. So this is not 0. Okay, so let's go to 3. If we use 3, we'll have 3 minus 11, 3 squared minus 14, 3 plus 84. This is 27 minus 99 minus 3 times 4, that is 12. 3 times 1, so we get 42. And then plus 84. So let's see what we have now. 27 plus 84, we have 7 plus 4, that is 1. 11 there. Remainder 1. 2 plus 8 is 10. So we have 111 minus 99 minus 42. That is 1 there. Remainder 1. 9 plus 4, that's in 13, 14. not 0. Okay. So the factors of 84, 4 is also a factor of 84. So let's go to 4. 4 power 3 minus 11. 4 squared minus 14. 4 plus 84. Here we have 64 minus 16 by 11. 16 by 11, we get 61061. That is 671. That's 176. Minus 14 by 4. That's 28 plus 28, which is 56 plus 84. So we add again 84 plus 64. This will give us 8, 14, 148. So we can see this is not 0. Okay. 5 is not a factor of 84. What about 6?
Sir, excuse me, sir.
Okay.
-3 gives.
-3 gives?
Yes, sir.
Okay, so I've been skipping the negatives here. I didn't realize that they could also lead us to the same thing. Okay, let's see. -3 squared minus 14, -3 plus 84. -27 negative, and then minus 99, and then plus 42 plus 84. So -27 minus -27, so 27 plus 99, that is 16, carry 1, 11, 12, so 126. So we have -126 plus 6 there, 12 here. Okay, this is 0. Good. So we have found 1, which gives. So when we find a -3 giving us 0, then we bring in synthetic division. Synthetic division, you go to the polynomial and get the coefficients of the polynomial, starting with the highest degree. The coefficient of x power 3 is 1. The coefficient of x squared is -11. The coefficient of x is -14. The coefficient of, the constant now is 84. So you don't go the other side. So meaning that if there were numbers after the equal sign, we bring those the other side and then correct the coefficients. And then just demarcate here. Then get the first number, drop it down. Then you multiply now. -3 times 1 will get -3, and then add. When we add, we'll get -14. Then you multiply -3 by -14. So that will give us a negative, that will give us -42. So -42. Let me see if I'm confused here or not. So we have 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1 down, and then -3. Then we add them, we'll get -14. Okay, then you multiply -3 by -14, we'll get +42. You can see the confusion. Then we add. So adding, it will be 42 minus 14. So we'll get 8 here and get a 2. So we have 28 positive. Then negative 3 times 28. So 28 by negative 3. So first multiply by 3. So 3 by 8, 24. Carry 2, then 6, 84. So we'll get negative 84. When we add, we have 0. So what we have now is x minus the 3 that we got. So that's how we always write. So we write x minus k, k being the number that we have used. So in other words, when what you have outside here is negative, you write x plus k, which we have now seen. So I'm going to write it in that form. So say x plus 3 multiplied by, I'm getting this as a coefficient, so I'll say 1x, then the power, because we had power 3 here, we now have power 2. And then minus 14x, and then plus 28 is equal to 0. This means x plus 3 is 0, or x squared minus 14x plus 28 is 0. So now we work on this quadratic equation, which is the product is 28. So the factors should be, if the sum is negative 14, what are the factors? So this guy then look like their factors. 14, let's see, 7, no, it can only require 7 again. So we may not have factors here, so we can use the formula. So to use the formula, let's check the discriminant. B squared minus 4ac. Let's check what this is. So b squared, that is 14 squared. 14 squared is, what is 14 by 14? 6, carry 1, 4, 5, 0, 4, 1, 6, 9, 196. So we have 196 minus 4 by 28. 28 by 4, that's 2, carry 1. That is 8, 9, 92. So the roots are there because the discriminant is positive, and it is 104. Except that it's not a perfect square root. So it will give us a lot of issues when finding the critical numbers in between, but we have no option but to do so. So we have x is equal to negative 3. From x plus 3 is equal to 0, we obtain x is equal to negative 3, 1. And then from this quadratic here, it is x squared minus 14x plus 28 is equal to 0. Now we are saying x is equal to negative b plus or minus the root of b squared minus 4ac over 2a. giving us negative b, which is negative 14, plus or minus b squared, which is 14 squared, minus 4, a is 1, and c is 28. Everything over 2 by 1. So we'll get 14 plus or minus, we found this number here to be 104 over 2. Now let's see, could you find a number that we can multiply two numbers, one a perfect square, so that we can reduce 104? Or we can leave it like this. It's okay. So we know that 104 is bigger than 100. The square root of 100 is 10. So this number is bigger than 10, but less than 11. So it's 10 point something. So when you have 14 plus this over 2, it's the same as we're having 14 plus 10, that is 24. 24 over 2, that is 12. So we have 12 point something. Then 14 or 14 minus 10 point something over 2, that is 14 minus 10 point something, that is 4. So now it will be 3 point something.
Yeah, I have a question.
Okay.
How many formulas are we supposed to use? Because the first we used the one for b squared minus 4ac. Now we've moved to this one.
Now, so we just wanted to use this one to check if it would be necessary for us to use the whole thing. Because if this one gave us a negative number, we wouldn't have gone for the whole quadratic formula.
Oh, okay.
Yes. So we have, this will give us, we said 14 minus 10 point something, which will be 3 point something, divided by 2. So this number will be 1 point something. Of course, bigger than 1.5. We just wanted to know the whole numbers attached to these. So we have 12 point something and also 1 point something. Then now, so from these two, we've gotten those. So far we have x is equal to negative 3 as a critical value. We have x is equal to 12 point something. We also have x is equal to 1 point something. So let's go back and check what we have in the denominator. In the denominator, we have 3x plus 9 and x plus 5. So we have 3x plus 9 equated to 0. It will give us 3x is equal to negative 9. So x is equal to negative 3. When you divide by 3 there, we also have x plus 5 is equal to 0. So x is equal to negative 5. So we have 1, 2, 3, 4, 5 critical values, but negative 3 has repeated. So it will only appear once. So we have 1, 2, 3, 4. 4 critical values. So now we can test. So we'll have, which one is the smallest? Negative 5. So we'll have negative 5. We'll have negative 3. And then we have 1 point something. And then we'll have 12 point something. So we need all of them. And then get now, the numerator has 2 pieces. It has x plus 3. So we'll get x plus 3. It also has this product, this quadratic x squared minus 14x plus 28. So x squared minus 14x plus 28. It's also needed when testing Then the denominator has 3x plus 9. 3x plus 9. It also has x plus 5. And then the whole thing, I'll just call it f of x, meaning the fraction thing where we get the whole numerator divided by the denominator. So I want to test now. So pick a number less than -5. A number less than -5 can be -6. A number in between -5 and -3, -4. A number bigger than -3 but less than 1, 0. Here you can get 2. Or since it is too close and we are doubting there whether it was 1 point what, maybe it could be 2. So since we still have space, we can use 3. We are sure it's very far from that. And then after 12, we can use even 20. So I've gone for the one with a 0, maybe it will be easy to multiply. Then now we test. So we get -6 in the first one, it will give us a negative. -4 in the first one, it will give us, first we'll be getting the line going down. So use -6, also -6 in the second. So we'll have -6 squared minus 14 minus 6 plus 28. This will be positive throughout because we are squaring it here. There are 2 negatives there, then there's a positive to be added. Then 3 by -6, that is -18 plus 9, you get -9. Negative here again. Then now multiply positive, negative times positive, you get negative times negative, positive times negative, negative. Then you got -4, it will give us negative here, and then -4, have it squared, minus 14, -4, and then plus 28. This is again a positive number because we have positive throughout. And then -4 there will give us -12, which is negative. And then +1. When you multiply, we get a positive. Then 0 will give us positive, 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 positive. So we'll get positive again. Then 3 squared, that will be 9, minus 14 by 3 plus 28. So let's see. 14 by 3, it was giving us 42. Now it's negative, then 28, so this will be a negative number. Negative. So then 3 plus 3, positive here. And then this will be +2, positive, so we'll get a negative number. Then 20, that will be positive. This will be positive. This will be positive. So we need to check the middle part. So 20 squared minus 14 by 20, then plus 28. So this is 400 minus, let's check, 140 by 2, that is 14 by 20. We get 0, we get 8, we get 280. So 280, so this will be positive. So we have positive here. So we want where it is what? Let's go back to our question and check what we've been looking for. An interval where this guy is greater than 0. So where it is greater than 0. So the solution set is going to be starting from -5 all the way up to -3 union. So even if you have plus, we have plus, we have plus. We need to demarcate them because we cannot use -3. We won't get a plus. That's why it's a critical value. So union, start again from -3, go all the way up to 1. Union, start from 12. Remember, this is 12 point something, so we won't write 12. We'll go back and write the original thing since we don't know the actual value. So that was the original number there. It was 14 plus root 104. So it was 14 plus root 104 over 2, comma, infinite. So this becomes our solution set. So some questions can be too long that they may never be assessed. We may never be asked to do that in an exam. But if we're asked to do that and we have time for it, that is what we do. So what will happen is that maybe after 2-3 topics, I'll stop giving you tests. I'll be giving you something that looks like an exam. And then I'll teach you the tips. I'll give you the tips of how you must be attempting the exam. We don't just answer an exam from question 1 to question 5 because I've said answer 5 out of 7. There's a way we pick, even after picking 5, there's a way we answer them so that you are able to use your time wisely and clear. Because sometimes you can know things, but you fail to manage your time and end up finding yourself failing. So this is how you go about this question. So this question may be it's too long, so hope it does not confuse anyone. It has confused you. Just forget about it.
Sir, it's very long. Me, I'm confused.
Yeah, it's very possible. And what made it long is a numerator that had a complicated critical values. And the procedure is just the same. So what took us long was calculating the numerator, getting its zeros. You can see this whole part, the zeros of the numerator. Again, we even failed to get actual values. We just use the estimations. After that, we just add the page. We're able to get the solution set. Okay, so when you are still on inequalities, I'm not so sure if, let me check into sheet 5 if there's a piece where we'll have to talk about absolute inequalities, or we just squeeze them here. Okay, so I can't see that into sheet 5. I don't have 6, I would have checked. But I think 6 is for binomial, so meaning that we don't have that such part, so we'll tackle it here. So let's look at, when you're still dealing with inequalities, let's look at the inequalities that comes with modulus. So we'll do examples of modulus inequalities. So 1, the question will always be solved for x. So 1, if you have x plus 1 less than 3, what we do is you must note that the modulus of x is always defined as the very x if it is positive and multiplied by negative if it is negative. What do we mean there? If the number given is 2, we just get it as 2. But if the number given is negative 3 and you want to make it positive, you multiply it by a negative. So that you have negative times negative becomes positive 3. In other words, we are saying the purpose of the modulus is to make a number positive. So the purpose of the modulus is to make a number positive, always. So that if you don't want to use the modulus, you can as well just multiply the number by a negative. Since it is negative, then it will become positive. So that if a number is already positive, there's no need of the modulus and there's no need of multiplying it by a negative. So because of that, we have this modulus of x plus 1 is defined in 2 ways. It is x plus 1 or negative x plus 1. So since what we are having is less than 3, we have something like x plus 1 is less than 3 or negative x plus 1 is less than 3. If we divide by negative, we'll have x plus 1 is greater than negative 3. So to avoid solving like this every time, whenever you find a question, the modulus of x plus 1 less than 3, your next step should be get the negative 3, let it be less than x plus 1, and then fix it less than 3. Then take one the other side, take one the other side. So now we'll have negative 3 minus 1 less than x less than 3 minus 1, giving us negative 4 less than x less than 2 as our solution set. Okay. Then, so for this case, it will be easy this way when we just have x plus 1 there. But what if, so this was labeled 1, okay. What if we have x plus 1 over x minus 3 less than 5? It will be the same. We'll say negative 5 less than x plus 1 over x minus 3 less than 5. So at this point, it has now become just like these inequalities here. These ones. Okay? Just like these inequalities here, where we have this thing greater than that thing, like that, where you have -2 less than this, less than that. So meaning that you break it in pieces. Okay, so you break it in pieces. So you say, I have -5 less than x plus 1 over x minus 3, and x plus 1 over x minus 3 less than 5. So the first piece, we can take this to the other side so that we have -5 minus x plus 1 over x minus 3 less than 0. So over 1 here. And then let's solve this first, then we'll get back to the other piece. So this one, get the denominator and then have -5 x minus 3 minus x plus 1 less than 0, giving us -5x plus 15 minus x minus 1 over x minus 3 less than 0. Simplifying this, we'll get -6x plus 14 over x minus 3 less than 0. Critical values, -6x plus 14 is equal to 0, giving us -6x is equal to -14 divided by -6 divided by -6. So x is equal to 14 over 6, which is 7 over 3. Dividing by 2 there. And also x minus 3 is 0, giving us x is equal to 3. So 7 over 3 is 2 point something. So meaning that when we get the critical numbers, we have 7 over 3. We also have 3. A number in between, we don't have any whole number in between these two numbers. So what we'll do is we'll add them. We'll get 3, 7 plus 9, which is 20.
Yeah, I have a question.
Hello.
This part on -6x plus 14 over x minus 3, forget about the denominator.
No? 6x plus 14 over x minus 3, is it?
Yes.
So you get 6x, -6x plus 14 is what we have here. So
Yes.
for x, we get this value here, is it?
Yes.
Then get the denominator also. So for x.
Oh, thank you.
Okay. So we have critical values now. So because we don't have any whole number in between these, so we must look for a number in between this. So the easiest way is you add the two numbers. So we'll get 16 over 3, then divide the whole by 2. So dividing it by 2, 2 here goes 1, 2 there goes 8. So we'll have 8 over 3. So 8 over 3 is a number in between 7 over 3 and 3. A number bigger than 3 can be 4 or any number. Less than 7 over 3, we can use 0 the easiest, and then get -6 plus 14. Also get x minus 3 and get the whole plus 14 over x minus 3. So we have that goes there, goes here, here. So if you use 0 here, it will be positive, negative, giving us negative. If you use 4, we'll get negative, positive, negative. Let's see in between here. We are getting negative here because it will be 8 minus 3 minus 3 over 1. Common denominator is 3, so we'll get 8 minus 9, which is negative. What about the other one? So let's use this same space to create the other. So it will be negative 6 multiplied by 8 over 3 and then add 14. So this will be 1 here, 2, so we have negative 16 plus 14, which is negative. You multiply, we get positive. We want to get where it is less than 0. So our solution set this far is from negative infinity up to 7 over 3 union from 3 up to positive infinity. So this here we'll call this solution set 1 because we still have this piece. So we haven't solved this piece yet. So we are done with the first piece. Now let's solve the second piece. So we have x plus 1 over x minus 3 less than 5. This is the same as x plus 1 over x minus 3 minus 5 over 1 less than 0. I emphasize never cross multiply. We don't do that. Okay. So here we have x minus 3 giving us x plus 1 minus 5 x minus 3 less than 0. So we'll get x plus 1 minus 5x plus 15 over x minus 3 less than 0. So we have negative 4x plus 16 over x minus 3 less than 0. Critical values. Negative 4x plus 16 is equal to 0, giving us x is equal to 4. And x minus 3 is 0, giving us x is equal to 3. So we form a table. 3, 4, again, no whole number in between. But if we add 4 plus 3, we get 7, and then divide it by 2. What we'll have is 3.5.
So,
Hello.
how are you finding the critical values again?
So you equate the numerator to 0. So for x, what you get is a critical value. You get the denominator to 0. So for x, what you get is a critical value. So not equating the whole thing to 0, like negative 4x plus 16 over that to 0. Equate the numerator alone to 0, also the denominator alone to 0. Then pick a number bigger than 4, 5, a number less than 3, 0, and then pick the numerator, negative 4x plus 16, the denominator, x minus 3, and then pick everything, negative 4x plus 16 over x minus 3. So we'll have this. So if you place 0 here, we'll have plus, place 0 minus, altogether get negative. 7 over 2, 7 over 2 minus 3 over 1 will give us 7 minus 6 over 2, which is positive. And on top there, negative 4, 7 over 2 plus 16, that is 2 here, 2, so you get negative 14 plus 16. This is 2, which is positive. When you multiply, we get positive. 5 will give us negative 20 there plus 16, which is negative, positive, negative. What do we want? We want to get it's less. Remember what we said? Whenever it's less, so I take you back there. When we have less or equal to, get the negative intervals. So let's go and get the negative intervals. So get the negative interval. So solution set 2 is negative infinite up to 3 union 4 up to positive infinite. The negative intervals. Then now to get our final solution set, we intersect solution set 1 with solution set 2. So what is solution set 1? So we just got solution set 1 here, negative infinite to 7 over 3, negative infinite to 7 over 3, union 3 to infinite, 3 to infinite is intersection. This one, negative infinite to 3, union 4 to positive infinite. So to intersect here, observe, to intersect here, between negative infinite and this negative infinite, you get the biggest number. Now you find that they are the same, so you would get negative infinite. Between 7 over 3 and 3, get the smallest. Now 7 over 3 will be the smallest here. Get it as it is. Union, move to this interval versus that interval. Between 3 and 4, get the biggest. The biggest is 4. And between infinite and infinite, get the smallest. Now you find that they are the same. So this is our solution set satisfying our inequality. X plus 1 over x minus 3 is less than 5.
So
Hello.
when getting the final solution, please run through it. I didn't quite get. What did you mean? You meant by getting the smallest and what?
So when you are getting, you want to get the intersection of the two intervals. So what do you do? Between the first interval and the first for the second, the left numbers, negative infinite, you get the bigger number if they are different. Now here they're the same. Then for the inside, 7 over 3 and the 3, you get the smallest. So you're comparing which number is bigger than the other. 7 over 3 and the 3. 7 over 3 is smaller. So we'll get 7 over 3, the smallest. Then leave the first intervals, go to the second intervals. Second intervals between 3 and 4, get the biggest. So for the left numbers, you're getting the biggest. So 3 and 4, 4 is bigger than 3, you get 4. Infinite and infinite, if they were different, you get the smallest. But now they're the same, so just get infinite. That's how you form your intersection. So we also have a different type or set of examples where they would ask you to 3 still solve for x. A, they give you x plus 1 over x. Okay, let me change the one there. It seems like that's stuck. So let's do x minus 2 over x plus 4 greater than 1. Now I'll put greater or equal to. So if there's greater or equal to, remember we said if it was this, greater or equal to 1, we demonstrate on the simplest one, we would say this guy is x or negative x. So it is greater or equal to 1. Okay, so meaning that we have x greater or equal to 1. We also have negative x greater or equal to 1. But we can divide the negative here. What we would get is x less than or equal to negative 1. So meaning that we will have two inequalities, this form and this form. Now, to avoid solving for this every time we meet this question, what we must understand is that if we have greater or equal to, or if we have greater, keep it greater or equal to 1, or get x minus 2 over x plus 4 less or equal to negative 1 now. Coming from this thing here.
Yeah.
Yes?
Can we still solve it there? We solve the other one by saying starting with negative 1, then greater than or equal to x minus 2 over x plus 4, greater than or equal to x minus 2 over x plus 4. What can I say?
You're right. This, what we have written here is the same as saying negative 1 greater or equal to x minus 2 over x plus 4 greater or equal to 1. But when you separate them, you have these.
Okay, sir. Thank you.
So now, let's do the first piece. We'll have x minus 2 over x plus 4 minus 1 over 1 greater or equal to 0. Or the second piece, we'll leave it in this form also. X plus 4 plus 1 less or equal to 0. So let's now finish the first piece. X plus 4, and then this will give us x minus 2 minus x plus 4 greater or equal to 0. Simplify, it will be x minus 2 minus x minus 4 over x plus 4 greater or equal to 0, giving us negative 6 over x plus 4 greater or equal to 0. So here, we only have one critical point. Since the numerator doesn't have any variable, so it will always be negative 6. So we only have x plus 4, that can be 0. So x is equal to negative 4 is our only critical variable there, our only critical value. So I'll test it from, let's do it from up here. So put negative 4 there, and then you demarcate a number bigger than negative 4, 0, less than negative 4, negative 5, and then you get negative 6 is not important in this case, so we just get the whole thing, x plus 4. Because even if we got negative 4, it will still give us, I mean, even if we got negative 6, there's nothing to substitute there. So we just get the whole thing. So when x is negative 5, we'll have negative 6 over negative 5 plus 4. This is negative 6 over negative 1, which is 6, which is positive. When x is 0, we'll have negative 6 over 0 plus 4, which is negative 6 over 4, which is negative. So our solution set 1 here, we want where it is greater or equal to 0. Remember, whenever it is greater or equal to, get the positive. So we'll get from negative infinity all the way up to negative 4. But because it's greater or equal to, it includes the numerator if there was a critical value in the numerator. Now there's no critical value in the numerator, so it will still be open. Would have included, would have used the negative 4, would have written negative infinity, comma negative 4 closed if negative 4 was not coming from the denominator. Now that it's coming from the denominator, we cannot close it, meaning we cannot include negative 4, because if we include negative 4, we have 0 in the denominator, which makes everything undefined. So take note of that. We do not include a critical value that is coming from the denominator, even if we have greater or equal. So let's keep solution set 1 and look for solution set 2. Solution set 2, we have x minus 2
Sir,
over, hello.
repeat on the part where you talked about the denominator.
Okay. So we are saying, since we have obtained the critical value from the denominator, which is x is equal to negative 4. After testing, we remember that we have greater or equal to. Greater or equal to allows the situation to have a 0, meaning you can include the critical value, the boundary number. But if that number is coming from the denominator, you do not include it. What we are avoiding is, if we include it, then we are saying there's a point when we can have negative 6 over negative 4 plus 4. But this situation will give us negative 6 over 0. And this thing is unknown. It is undefined. So we don't want to have undefined situation in our interval. That's why we would exclude it, even if we have greater or equal. Then, so now we'll take this negative on the other side. We'll have x minus 2 over x plus 4 plus 1 over 1 less or equal to 0. Giving us x plus 4 and then x minus 2 plus x plus 4 less or equal to 0. So we'll get 2x plus 2 over x plus 4 less or equal to 0. Then get the critical values. Equate the numerator to 0 and solve for x. So get x is equal to negative 1. Equate the denominator to 0 and solve for x. So x is equal to negative 4. Then test. So we have negative 4. We have negative 1. A number bigger than negative 1, still 0. In between negative 4 and negative 1, we find negative 2. Less than negative 4, we can use negative 5. What next? We get the numerator, 2x plus 2. Get the denominator, x plus 4. And get the whole fraction. We're looking for the sign of the fraction. That's why we get it always. So we have such a thing. Goes there, goes here. Substitute -5, it will give us negative here, so that we have positive. -2 will give us negative here, positive here, so that we have negative. 0 will give us +2, +4, so that we have positive. Whenever it is less, we get the negative. So the solution set 2 is going to be -4. We don't include it because it's on the denominator. -1 will be included because it's coming from the numerator when we actually have an inclusion, less or equal to. So -1 included. So to get our final solution set, what do? We get solution set 1. In this case, we get solution set 1 union solution set 2. So it's different now. When we have greater or equal to, we'll keep our solution sets and get the union. When it was less or equal to, or just less, we got the two solution sets and then intersected them. So what we are doing now is we are getting the union of them. So solution set 1 is -∞ to -4. -∞ to -4 union solution set 2 -4 to -1. So this is just the union of itself. It cannot be brought into one interval because the other one is ending at -4 and the other one is starting at -4, but none of them includes -4. So they are separated for the reason of skipping -4. So that becomes our solution set. Then the next thing is, so this was example 3. Example 4. Oh, you had called it A. Let me check. You had called it A. So this one will call it B of example 3. B, you now have light situations where you have x minus 7 over x plus 18 greater or equal to -4. The solution set here is always all real. Why is it always all real? It's always all real because the modulus is meant to make a number positive. So whatever will be released by the modulus will be positive. And any positive thing is automatically greater than a negative thing. So that if we had the same question, less than or equal to -4, the solution set would be empty because we never have the modulus giving us a number that is equal to a negative number or less than a negative number. All positive numbers are bigger than negative numbers. So whenever I find the modulus less than a negative number, I don't do any solving. I just write the solution set is empty. Whenever I find the modulus greater than a negative number, I don't do any solving. I just say all real numbers will suit this thing. So what have we said? From this one, we are saying it's all real numbers because the modulus gives out positive values. Which are always greater than negative numbers. So let me say a negative number. And then for a second one, for C, it's empty because the modulus can never give out a number. The modulus can never give out a negative number. That is the reason why it is like that. Unless we have questions. So if you have no questions, we can end our class here. And I'm not giving you end tasks for today, but we are done with inequalities when it comes to solving. The next class, we'll continue with the tool sheet. We'll go back to question 2 until we finish that tool sheet there. And then we are very sure that on Saturday, as agreed, in the evening we'll have an assessment, because we should be done with functions, so that we end here for today.
All right, sir. Thank you very much. The class was very clear.
Thank you.
I enjoyed.
Thank you, sir.